All right. Guess we can start.
What would you like me to do?
Did you wanna whatever you wanna do? Did you wanna look at like the checkpoint and like commands for the regression one and then 7.1, 7.2?
Okay. You you want me to open the ones I have?
Let's open the one like I sent you and then
Oh,
like
the one you sent? Okay, cool.
let's open up like a new file and we'll like kind of like go over each one like one by
Okay,
one.
okay,
I'll help you like write each line.
okay.
Hmm.
All right, so that's one.
Yeah, I think it's the let's take a look at it. Try downloading. Try go to the email like the one I sent like six files I think.
Yeah, they are these ones.
Yeah, that one. Try click on the email, not the file, but click on the email. Yeah, click on the email, and then let's take a look at the one at the bottom. Why is it doing that one? Just click on it. Oh, there. Okay, okay. Go
Okay.
down to the bottom. Okay. I think I sent you the. That's the one, the regression one. The one on the left.
Yeah, that's regression 6. Yeah,
This guy on the left. The not the PDF one. This guy. Yeah. Let's open up that one or
this
download it.
one.
Yeah.
Okay.
Yeah. We should go over this one because last time we didn't go over this one, so it's really good because there's so many commands in there, but it was really long though. It's just too long. Okay.
Where did it go?
Oh,
I thought it was opening up.
try double click it. Okay, let's see. Maybe it's just taking a while.
Yeah.
Try to try opening up the R. Oh wait, try opening up the R Studio.
Okay.
Hmm. It looks like it's loading. It's just taking a while.
Yeah, my system is really slow. I think there's a lot of junk in it now.
That's fine. I like if you guys are using are you using a laptop?
Yeah.
Okay, that should be fine. Yeah, this is loading now. Okay. Hmm. Okay, there you go. Finally. Okay, let's take a look at maybe like open up like an empty file first.
So I go here.
Yeah, a script. Yeah, and then like we'll go through like how you would code this.
Gotcha.
So the first thing you should always like clear your console.
Mm, okay.
How you do that is like I guess
Okay.
just remember this code. It's a cat, cat.
Mm-hmm.
Okay, cat, and then parentheses cat like cat.
Oh, like CAT. Gotcha.
Yeah, put it on. You always want to write your code on the script though.
Okay, so I go to the script.
Yeah. So this is how I usually clear the console. So
Okay.
cat and then like parentheses. And I would put like this like forward slash or but an F.
Forwards, just one forward slash,
Yeah, just one forward slash.
and
Or
then
whatever.
an F.
No, actually, it's the backslash. Do you know where the backslash is?
Yeah. So do backslash F.
Yeah, and then usually it's like you need to put a parentheses, put these guys in a parentheses. Yeah, just put them in the parentheses. Yeah, like that. Yeah, and then the other one, the opening one after cat. Yeah, and then like you put back the double quotation marks. What you had earlier was right. What with the quotation marks.
Right there.
Yeah, like this one right here. Let me see if I can. Actually, I can't even. Yeah, like that. But then put in another one after the F. Put another one after the F. After the F, like
Or after the F.
yeah.
Okay, so that F is in it. Gotcha.
Yeah. And so like this right here is pretty much clear. Like try running this one.
Mm-hmm.
So here you didn't really see it, but then it cleared your console. Okay.
Okay, that's how you do it.
So usually that's what I do so that like there's nothing confusing with the outputs. So maybe try like the very first thing is like you always wanna type a few like installation packages and libraries, right? So maybe try like so that try and look at my the homework regression file and then like maybe just copy the preliminary one.
Where is it?
Yeah, it's over here. You know where next to the untitled, it's up top, the homework regression. It's inside R already. The one that you were looking at earlier. Do you remember the one that we were looking at earlier? It's
Oh,
already
go back to the homework.
the one that's already in there, right? The homework regression. It's already in there.
It's in here.
Not that one. It should be in the homework. It's in R Studio. It's already in R Studio.
Or is it already in R Studio? Okay, gotcha.
Yeah.
All right, so the R Studio.
You know the homework
So,
regression.
oh, you're talking about this.
Yes. Yeah.
Okay,
Just copy like everything from like. So it's like I think it's better if we do this. Just copy everything from line 6 to 14. Yeah, 6 to 14. I think that, and then I'll just explain it. Okay, and then like put it in like where you were earlier. You already have a new one, right?
yes, but now I don't know how to find it.
It's in Untitled 4, I think. It's the one next to it.
This one.
I think it's that one, yeah.
Oh, you see, I never know how to find my stuff.
Yeah, I think it's good to maybe save it. Let's try saving this file. It'll be easier to try saving the file. Yeah, just save it, yeah, and then like let's name it. Let's actually name it so like you can find it. Okay, I think the best way to find it is probably where do you want to put your file?
Okay, so do I save it here first? The one inside here?
Yeah, just save that one first, yeah. But yeah, you have to save this somewhere. Go to desktop. Maybe go to desktop. Yeah, and then like just name it something. So what do you want to name the file?
So I'll name it 6.
Oh yeah, you have an Asus computer?
Yeah, this is Asus.
Oh man, you have the best one actually.
I think you are right because I've had it for 4 years and it's never even get hot. No other thing except I broke it down a lot.
It's pretty expensive too, right? The Asus computer.
Yeah, but it's better than HP. I've been using HP all along, but this was the first time I bought something not HP. But
yeah, never buy HP. I can tell you, like, ask me if you want a computer advice. Like the best one is Asus, and have you heard of Lenovo?
Yeah.
Lenovo is also good if you're gonna be doing like statistics, statistic works with like R. You definitely Asus is like the best one, so you're good to go. Okay, and then so after you name it, you need to put .r, like so .r, like up here.
Excuse me.
Bless you. So period R, put in period R. Yeah,
R for studio.
yeah. And then like this is how you save the R file. So try save it. There you go.
Thank you.
So now you have it saved the same as like what I did. And then you saved it in desktop, right? So it's easy to find.
Oh, okay, got you.
Okay. Okay, let's try I guess for this one I was just trying to show you how to like do it. Try deleting line 1. The first one, yeah. That was just to I think it'll be okay. Try delete that one and then let's take a look at let's run line 3 to 10. Yeah, okay. So what it's doing now is you're gonna be installing all these packages, right? That you're gonna need for your program. And okay, that's good. There you go. It's doing it. It's doing the tidyverse. And then you're gonna be doing some plots. Have you heard of ggplot2?
I just had the teacher talking about it, but yeah.
ggplot2 is like one of those things. If you're gonna be using R, it's like what you use to plot. Yeah.
The
Okay.
one for the graphs.
The one for the graphs. Yeah.
Yeah, it uses it, but I don't know how he gets the graphs.
I'll show you. We're gonna use it here. Okay.
Oh.
So I think we're done. We read the lawn file. That's like what you need to do for this one.
Okay.
Let's go back to the homework file, regression R. And then like copy 16 to 18. Yeah, try. You can copy it, but we have to put. Okay, you can just copy it. Yeah. Yeah, you can. I usually put like a space so that like when you're looking at your code, it's like, oh, okay, this is step 1, step 2. Yeah, space or 2, it doesn't matter. But as long as you can like look at which one is which. Okay, so for line 14, this one is usually it's not really code. Let's hashtag that one. Let's make that a comment. Line 14.
Or make it a comment.
Yeah. That was just like to give description somehow. So this is the question. I pretty much copied everything in here, so we don't have to like go back and forth.
Oh, okay.
But yeah, like I'm thinking about like how to make this more simple. So like, okay, what is this question 1 asking you?
So
it says it right here. I kind of just typed it on line 14.
So it's saying a lawn care company tried to predict the demand for its service by zip code, using housing density in the zip code as a predictor.
Yeah, I don't really like how they do this. Yeah, you have to scroll to the right.
Yeah, the owners obtain the numbers.
I wish they had
So
like
try to predict demand by using the zip code.
Try scroll to the right. There's more to it. Just scroll the bottom bar. The gray one, not this one, the horizontal one.
The horizontal one.
This one, you see in the big gray bar, that one, yeah. This one in the middle, yeah, that one, yeah.
Drag that. I didn't know I could move it.
You can move it, yeah. No, it's pretty nice.
Okay.
But the thing is like I don't like how you have to do this.
Yeah, back in, yeah, like going to go having.
Because like it's usually in like some programs.
I never knew it moves.
Some programs like they have this word wrap where if it cuts off, it puts it at the next line. Anyways, yeah. So what's the question?
Okay, so then it goes on to say obtain the number of homes and geographic size of each zip code, calculated the sales per thousand homes and number of homes per acre. What is the correlation between these sales and density? So that's one piece, and then report in 3 decimal places.
Yeah, perfect. So it's wanting you to do the correlation, right?
Yeah.
I kind of put the answer there, but let's try to figure out that's ANS. That's the answer. The line 15. That's actually the answer.
Mm-hmm.
But then let's figure out how I did that. So if you do line 16, try to run that one.
Line 16.
Yeah.
Run it.
Yeah, let's run that. That's just that one, yeah. Okay, so that's what I got. And so what is correlation? Correlation is like you're comparing two numeric numbers, right?
Mm-hmm.
And then these two are the sales of like I guess this lawn care company, and then the lawn density, right?
Mm-hmm.
So like if you look at the sale, it's actually not that big of a like of a file. Like the sales and density are the only columns they have. So if you take a look at density, like you see
Mm-hmm.
density, the column,
Yes.
you see how it's decreasing.
Yeah. So it starts from 6.5, it goes down to 4.2.
Yeah,
Then
it's decreasing, right?
mm-hmm.
So and look at your sales. What is it doing?
Well, the sales it fluctuates.
Fluctuates, yeah. But like in like generally, what is it doing? Is it increasing or decreasing? Scale
Generally, it is increasing
up to like 115. Yeah, after 115, it's
up to 115. Then it starts to decrease.
yeah. It's I guess so. What I'm trying to say is, so when your sales is like increasing, your density is decreasing, right?
Mm-hmm.
So that's why it's negative. That's why the correlation is negative. Does that kind of make sense? Like that? That's why it's negative 0.771.
So when the sales increase, the density will decrease.
Yeah. So like if you take a look at this, like the more sales you have, the lesser density you get.
The less number of homes you have left to sell.
Yeah, that's like yeah, that's pretty much what this correlation tells you, yeah. And how you calculate that? Uh, how does this command look? Round core. Does that look familiar? We did this before, kind of like the correlation.
Which one is it here?
Yeah, on line 16, you see there's core lawn sales, lawn density.
Ah, yeah. So this is the formula,
Yeah,
the
do you remember
calculation.
we did that one, right?
Yeah.
So you just do the same thing. You have core of the lawn sales, and then I think the first argument is like your response, right? The one that you're trying to predict, right?
Mm-hmm.
And then your predictor is what your density. I think that's what it's saying, right? Your predictor is the density. So that's usually like your second argument. So you have your first argument.
So then the density would be on the y-axis if it or the wait.
For this one, it's I think how did we do it in the other ones?
Okay, so
We did this one before.
Yeah, we did this before. I think I got the notes here. Okay, yeah. So the density is the predictor. The sales
Or is it the other way around?
is the sales the predictor.
Is it the other way around? Let's see if you have to like switch it. Try switching it. Let me look at this one. Because we did
Okay.
this in like 6.2. 6.2. Let's look at 6.2. Take a look at 6.2. So you predict what goes from budget. So it should be the other way around, I think. And let's
I mean, it should go here.
yeah, try switch those two. Switch those two
Okay.
things, yeah. Because like what I got for 6.2 is I think when you're doing the LM, you have to put the Y first, but if you're doing the correlation, you have to put the X first.
Yeah, the X and then the Y.
Yeah. So density and then sales.
Okay. So then that would make density the predictor.
Density is the predictor, and then the predict what you're trying to predict a response is sales. You're still getting the same thing because it's like it's pretty much a
Mm,
correlation.
right.
And let's see. Did you run that one?
Not yet. So now-
Let's take a look at this.
okay, I ran it and it says uh,
Okay, it's still the same number, but okay,
yeah,
it's still
it's still the same number, the 0. The negative 0.771. Now, this complete thing, can you explain it one more time to me?
complete right there is like if you have any like holes in your data, it just does it just fills it in. And this one
Like
you
outliers?
yeah, like if you have like holes in your data, like it skips, there's some holes in your like cells that are not filled in. It'll
Oh,
just
the
tell
ones that
you.
are like, okay.
Yeah, that's what it is. But then
Oh,
I usually put that one.
okay. Just in case they are there in the data set.
Yeah.
Okay.
So okay. The next thing is question two, or yeah, question two. Let's try to copy that one.
Okay. Let me go here and then go here. And then I'm going to take line 20
Okay.
through 21.
Yeah, this one. This one is pretty much just looking at and interpreting. We just have to interpret what question one is saying.
Okay.
Yeah. Is this more effective than like I'm trying to see which way is more effective? Like I, if you type it, is that better or is it better if you just copy it?
I think copy and paste is better.
Okay. All right, we'll do that. So when you do this, what does the sign? What's this asking?
Okay, so I'll move that a little bit. Okay, so it asks what does the sign of the correlation in the previous problem mean? So
Okay.
that previous problem was the
It's pretty much asking about the correlation, right?
yeah, was asking about the correlation between the density and the sales.
Okay, so what is this correlation? It's a y over x. Is it y over x? It's like sales over density, right?
Yeah, sales over density.
Okay, so response over predictor. So negative, it's a negative number, and it's less than one. What does that tell you? I'll ask you first. What does that tell you?
If it's a negative, that means there is no correlation.
If it no like correlation can be negative or positive, right?
Yeah, you're right.
Negative, I think it's like -1 to 1, something like that. But like if it's negative, that that means like the density and sales they're inversely proportional, right? So like if then so this one it's that means like if sales goes up, density goes down, or density goes down, sales goes up, right?
Mm-hmm.
But since density is at the bottom, um, if sales goes up, like and then this number is less than 1, what does that mean? Like if density is at the bottom,
Okay, so if this number is less than 1,
yeah,
mhm,
that means the bottom is bigger, right? Your predictor is bigger,
yeah,
right?
so the predictor is
Higher,
higher.
right? Isn't that right?
Mm-hmm.
So in this case, like what is that? Density, right?
Yes,
So so higher density means what for the cells?
we have higher density, then you expect more sales.
Yeah, that's good. But do you always expect it though? I think we saw from the graph, it's not always the case,
Yeah,
right?
so
Not the graph, but the
that
table.
is, yeah, that's the assumption, but it might not happen in reality because there could be something happen in that neighborhood.
Yeah.
It could be that there are some factors that may not make even the sale go up if, let's say, it's about neighborhood with like a lot of problems like violence, what have you. It could
Yeah, yeah. So what do you think? I think the answer to this, what do you think the answer is to this song?
so um so higher density tends to have lower sales.
Yeah, but look at the first one though. It says like it's kind of similar, right? The first one.
Yeah. Um,
But then like it says guaranteed, right, for the first one.
yes.
But it's not always the case, right? It's not always the same. It's not always increase. High density area means low sales. It's not always the case, right?
Yeah, because it can depend on the neighborhood, the type
Yeah.
of neighborhood.
But in general, like w- we can say that it does. The high density does show lower sales, right? The
Yeah,
more,
that
more
I can say,
houses.
yeah, that I can say yes to because yeah, you might invest a lot of houses
Yeah.
in a neighborhood. It doesn't mean that because there are so many there that people gonna go come over and buy quickly.
Yep. Yeah. I know. There's a lot of factors. Yeah. There's a lot of factors. So, what do you think the answer is to this one?
So I think it's higher density areas based on this result here.
Okay.
it's less than it's less than one, -1, so it's the correlation is not it's not that close.
Okay, but like I think for this one, shouldn't we just like look at the comparing the density and the sales?
Mm-hmm.
So that's what I put. I pretty much just compared it, but I know it's not always exact, so it's not always like guaranteed. I just put like okay 10, and that's what I got. I think that's the answer.
Yeah, I would agree with the answer based on what I'm seeing.
Okay, let's look at the next one.
Okay, so let me go here and I am going to come out with 23 through 25.
Yeah, this one. Let me think about this one. Model was fit to predict.
Okay,
Okay. This one's a little bit hard, but let's go through it.
okay. So
So what is this question asking?
question is asking me, the model was fit to predict sales from density.
Okay.
What is the best way to interpret
Oh, it's not a long one. I thought it was a long one. So, okay.
of the intercept?
Okay. So like this is kind of like the y-intercept, right? Or like whatever. Then the intercept of your slope line. So what would you do in this one? We did this one before.
Okay. Mm, let me run it.
Okay. Let's run it. There's a bunch of tables there.
Yeah,
Let's look at it.
let me run it. Look at the results.
So do you remember doing the linear model? This is the linear single linear regression.
Mm-hmm.
So for this one, like, what did it give you? It gave you something, right? It gave you like two things.
I am seeing. Okay, so let me see here. What's the best interpret the intercept? And you're looking at summer sales intensity.
Yeah, the Y is
The
always in the.
intercept is right here.
That's the intercept. Yep.
So 141.525.
Yeah, but like, how do you interpret that one? What is the Y-intercept?
That's what I'm struggling to understand. Because this
Okay.
has to do with the t-value, t-value.
Okay, I'll explain it. So, do you remember the equation of the line? Like Y equals mx plus b?
Yes.
So, a regression line is also as a linear regression. It's just a line, right? It gives you a line.
Mm-hmm.
So, if you remember that one, the m that's our density, right? That's not density, but that's the slope, right, of our line. And then our slope is the next value, the negative 12.893. That's the slope, right?
Mm-hmm.
But then our intercept, y equals mx plus b, the b is the intercept, isn't it? Like
Yes.
what? So that b, do you remember what that meant? Like if you had a b, what was your x for b? Like in order for you to get the intercept, what was your x? X was 0, right?
Yeah, x equals 0.
Right, to get the y-intercept.
Mm-hmm.
Eh, okay, does that make sense though? Like if you put x as 0, then you get a b.
Yes. Mm-hmm.
Let me see if I can. Sometimes I can write this on my iPad. Let me see if I can write something. Is there? Let me see. Can you see what I'm writing right here?
Yeah.
Oh, you can see it. Okay. I usually don't use this. That's why. But let me see if I can write. So, oh, come on, man. Why is this the eraser? Why is it doing this? Oh, okay. This is not friendly. Okay. All right. So y. And bear with this. Is like it's really bad.
Mm-hmm.
mx plus b, right? Right.
Mm-hmm.
And then what is this? What is this guy?
That's the intercept.
This is the intercept, right?
Yes.
I'm just gonna abbreviate. I don't want to write the whole one. And then
Right.
for ours, hold on. Let me just name all of them. So this m, this is our slope, right?
Mm-hmm.
And then what is this one? The x. This is our what? This is our predictor, right?
Yeah, that's the predictor.
Man, I don't want to write the whole thing. Right? Predictor. And then this one is our. What do you guys call it? Do you guys call it response, or what do you guys call this one?
Response
Okay, so this is the response.
or
And then okay,
size.
okay. So for us, what is our response?
The response is the Y.
The sales one, right? For us.
Yes. So it will be the cells.
Okay, and then the predictor. Which one is this one? Our predictor.
So the predictor will be the density.
Okay, this is the density,
Mm,
right? Density. If I can remember.
yes. Mm-hmm.
Density. Okay. So in order to get, let me change color. In order to get this guy, the intercept.
Mm-hmm.
What did you have to do with this one?
Mx.
Yeah, like in order to get B, what did you have to do with this guy? It has to go to 0, right?
Yeah, x equals 0.
So x has to equal 0, right?
Mm-hmm.
The slope isn't 0, obviously, right?
Yeah.
Because we have it right here. The slope is this guy. That one, whatever. Oh,
The
man, it's really.
141 point. No, that negative 12.
Yeah, the negative 12, that's the slope. Okay, so with that, since you have this equals 0, then so it's our equation becomes this guy, right? Y equals B, right?
Mm.
Okay, does that make sense?
Yeah.
Okay, so what was our Y?
Our Y
Like, what
was
does it stand for, our Y?
the Y stands for cells.
Okay, so it's sales, right?
Mm-hmm.
And then what's our Y, what's our B? What's our B? It's this guy, right?
Yeah, our B is the intercept,
141, right?
the 141.
Okay, 141, 525, right?
525.
Okay, so what did we do? That we pretty much got the answer. This is what the question is asking, right? So the question is, what is this y-intercept? So we got this one. This is our answer right here. So this y-intercept means that what did we do though? We did two things, right? What does this mean? F equals 0, x equals 0. What does that mean? Well, what was our x? Is this guy? X is what? This guy?
Uh,
Yeah, but does is it confusing or I'm trying to make this more sensible. So what was our x?
So the X, let me see. That's
It's
the,
yeah, X. Yeah, we have one X in this one.
so X is 0.
Yeah, but then what does X stand for? What is X?
X is the predictor.
And what is that for us? Like for this database, what is our
For
predictor?
this database, that would be the sales.
Which is what? Like
Sorry, the density, not the sales.
okay, so it's density, right?
Yes.
The density. Let me write this. Density. And you said the X equals 0, right?
Yes.
So this is 0, isn't it?
Yeah.
Okay, so this is what it gave us. This is the y-intercept. The y-intercept is 0, 0 density, and then sale. Then what does that mean? 0 density, and then also this guy. Sales is this guy, and then the density is this guy. So that's the y-intercept. Yeah, I know it's does that kind of make sense? Like that's the y-intercept is. It's pretty much just the line.
Okay. So
I'm gonna erase this now. Like, can I erase this one?
all right. So we are looking for Y.
We're looking for y, yeah. Which is this guy.
So if uh we got the X, which is 141.52, and the slope,
The 141.525 is B. That's B.
that's B.
Yeah, that's the intercept,
That's the intercept,
which is also y, right?
Yeah, which is all equals to Y.
Because the intercept means y equals B and then x equals 0, right? That's just the definition, right?
Mm-hmm.
Intercept means y equals B, x equals 0.
Yes.
And then we give it life. We give it physical meaning.
Yeah. So that's what I need to figure out. So if
Because
X
many times,
is
like,
0
yeah.
and plus B, which equals Y, so
Yep.
that will be 0 plus 141,525.
Let me just rewrite this one. This is just response.
And Y is the response.
Yeah.
Actually, which is equals sales. So sales,
Yeah, y equals B, and then sales is B. Like
okay,
sales.
so Y equals sales equals that's the 141.525.
Yeah, but then that corresponds to x equals 0 too, right? X equals 0, right?
Yes.
But then x is what? What is the physical meaning of x?
That's what I don't know how to.
The physical meaning of x is the predictor, right? The x is the predictor, isn't it?
Mhm.
Right? Is
Yes.
x is the predictor. But then for our data frame, what is our predictor? What are we doing? Our
So
predictor.
our predictor here in this database is the density,
And then the response is
and the response is the sales.
so in like the equation, the y equals b. So that's what is that?
That's the
That's
sales.
that's the sales. Yeah, good. And then the x equals 0. What does that mean?
So that equals the density.
So density is 0.
Yes. So density is equal to 0.
Yeah, which very much means like there's no housing.
So then that means that nothing is going on here.
Nothing's going on, yeah. So I don't know how you have sales. I know it's like a weird one. Physically, it
Oh,
doesn't.
yeah, so there's no sales going on in this zip code.
There's no housing density, but there are sales though. There are sales. I know it's hard to grasp, but like the housing density. I think housing density. What is housing density? Like, what is the physical meaning of that?
I would say like
I think it's the average number of residents, right?
the average number of residents in a particular area.
Divided by the area of the project, right? Or the place.
Yes.
So if the density is 0, that must mean there's no one there, right?
Yes.
So what does that mean for your sales? That means that it's gonna go up because then you have to sell it to people for them to come. I think that's the one way to explain it.
Yeah, I agree.
Yeah, it's kind of like once you give meaning to these statistics things, it's like sometimes
Yeah, that's one.
you have to make up a behavior somehow.
Yeah.
Okay.
Ah.
Okay. Can I erase this?
Yes. Yeah,
Okay.
you can erase the board.
Man, it's like actually I usually do this on iPad, which is like so much nicer. But
Oh, okay.
the thing is I can't do RStudio on the iPad, so we'll have to do with this with my mediocre art. All right. Okay. Let's look at the next question.
All right. The next question is going to be number 4.
Oh, I didn't put the stuff here. What did I didn't put the answer. Okay. What is this one asking?
Which one?
What's number 4 asking?
Number 4 is asking the model. The model was fit to predict sales from density if housing. Let's see here. If housing density increases by 5, what do we expect the sale to do? Indicate a decrease with a negative number and increase with a positive number. Report your answer in 3 decimal places.
Okay, so we started with 0, right? Like our housing density is 0.
Yes.
And now it's saying here it's gonna increase by 5. We just have to apply the equation. Yeah, I'll let you copy it first. What?
I didn't do something right here. That's the same question.
Yeah.
I didn't do good on that. Let me see.
I think it's the try doing the other one again. This is number 5. So try go back to the 4 one. I think the 4. Try doing the copy. Yeah, that one. Yeah. Just try copying and let's see. Copy. Okay. There you go. Okay. All right. So what is this one asking?
All
Remember,
right. So this one is asking if the housing that we talked about uh, density increases by 5,
okay.
what do we expect the sales to do? And then
Okay.
Mhm.
So meaning like we just apply the equation, right?
Yes,
Oh, you know what? I messed up the equation. Oh man.
this is talking about summary.
No, but I messed up the equation though. It's I forgot to add something to it.
Oh,
Uh,
okay, exactly.
do you see that equation on line 28?
This one
Yeah. Can you can you add 141.525
right here.
after the 5? Like I times it by 5, right?
Yeah,
Yeah. After the 5, just add the y-intercept.
and the y-intercept was the 141.525.
Yeah.
What do I put here?
Plus you plus it.
Yeah, you're right. Yeah, put a plus.
You plus is it's a positive intercept.
Alright, so only 141.25 digits 3.
Okay, try to run that one. The 28. I think just 28. Yeah. Okay, so I guess that's the answer. It's just applying the equation, right?
Yeah. Now
So
it says indicate in 3 decimal places. And I'm seeing here 2 decimal places.
yeah, I tried to the round. Try to delete that one. Try deleting the round.
This one?
Yeah, it doesn't really matter though. I think even if you did the math itself,
Mm-hmm.
um, just put in a 0 after the 77.06. Just put in a 0 after that one. I did the math. It's still the same number.
Okay, let's just leave it.
Okay, let's take a look at the next one. Yeah, this one isn't that bad. Let's go to question 5.
Okay, cool.
Okay, so this one, yeah, like you may have to put like a hashtag again in like line 30.
We're here.
Line 30, you have to comment that one.
Oh,
Is
okay,
this,
that's why it's giving me. Gotcha. There's no comment.
yeah, okay. So this one, what is this one asking us?
Okay. Then this question is asking the first observation has a density of 6.5 and sales of 54. What is the value of the residual? Report 2 decimal places. So,
You remember doing this one? We did the residual before, right?
yeah,
So what does the residual do again? Like what does the residual mean? Like what is that one?
it's the,
I think it's good to like these are good questions. So yeah, what does it mean?
I won't be able to explain it in statistical terms.
Yeah, just use those terms.
The low sales,
So which one?
low sales,
Low sales? Yeah, if so like for this one the no like you have that residual graph, the plot. I didn't really plot this one, but like if you have if you have like a high residual, that means like it's a difference between the observed value and the mean value, right? Something like that.
Yeah. Yeah.
But then like so yeah, the residual is the difference between the observed value and the mean value, or like the fitted value. And then so like the higher residual, what does that mean? Like if it's positive.
If let's see, if it's positive, that means they did they had better sales.
If it's positive, it's better sales, right? Yeah.
Mm.
And if it's negative,
And if it's negative, then it means they had poor sales.
okay, that's good. So let now let's try to code this. Do you remember? Like I have it right here, but then which part looks a little blurry? Like which part looks confusing? You remember doing this one? We did this one, but then we plotted it. So like for line 32, do you know what I did there?
Yeah, line 32. You did. So that would be, let's see here. The cells, I would take that would be the Y.
Yeah. So like for like the linear regression for single variables. Do you remember that one?
Yeah.
So like for line 32, I'm just trying to do a linear regression, right?
Okay.
And do you remember the LM command? We do that with the LM command, right? The LM,
Yeah.
right?
Yes.
Okay. And then like, so the residuals, how do we do the residuals? Residuals is just a command, right? It's just a command pretty much.
It would be that RESID thing.
Yeah, RESID, yeah, that one, yeah. So like when you do that, when you do the residuals of your linear regression,
Mm-hmm.
line 33, like when you do the residuals of your linear regression, the fit line, then
Mm-hmm.
that's how I got the residual values. Like the column residuals.
Right.
That's how I got that one from line 33.
So you got this one from line 32
The 32 line, what I did there is I did a linear regression first.
on line 32.
Yeah, but then in order to do a residual, you need to do a linear regression first. That's how you do it.
Oh, okay.
In order to do a residual, you need to do a linear regression. That's just how you do it.
Okay. So that makes sense now.
So once you have your linear regression, which is line 32, you need to just apply the residual function, residuals.
So
So
do linear regression
yeah,
and then do residual.
yep. But then now let's go back to the question. What is the question asking for? It's asking something about a particular thing, right?
Yeah, so the question wants us to know to tell what is the value of the residual.
But for which one? Which one? Which one are we looking for?
That would be for the sale. That would be for the sale of 54.
Okay. Okay, so that means like, which one is that? We have that one, right?
Yes, so that's this one here.
Yeah, the first one, right?
Yeah,
So we have what's the residual of that guy?
so that would be negative 3.72.
Yeah, so that's all you needed actually. That's the answer.
Oh,
Yeah, that's all you needed. That's what the question is asking, right? The value of the
mhm.
residual.
Yeah, that was what it is asking for. What is the residual? So we go to see question 6.
Yeah, but first, like, do you understand how I did that one?
Yeah, so now I understand it that in order to get the residual, you have to do the linear regression first.
Yes, yeah, that's the concept. You do the linear
Then once
regression and then you do residual. Yeah.
then is when you look for your residual for the residual.
Yeah. Okay, that's great. I'm glad you understood that one. Okay, let's look at the next one.
Okay. Ah, that is something now I can understand. Okay. So I'm gonna go for the next one right here. Question
Okay, this
6.
this one is just pretty much a concept. I'm hoping you can answer this one. This is a concept.
Okay. Okay. Question 6. How are the regression coefficients determined?
Yeah, how are they? Do you does your professor talk about this one?
Yes, he did. So yeah, and I think he had that question in class too.
And it,
So that would be
okay,
estimates of the unknown values or something like that.
the square, right? Square something, sum of
Yeah.
squares.
Yes.
But then, what do you do with the sum of squares, though? Like, do you remember the residual? So for the residual, what was it like? The higher the residual, the greater the error, right? From your like,
Yes.
right? That you're trying to do a
Mhm.
best fit line,
Right.
and then if your best fit line is not like if your points don't lie in your best fit line, they're really far away. You have a high residual, right?
Yes.
But if they're close to the line, the best fit line, linear regression, then you have a small error, right?
Yes. Mhm.
So what are you trying to do with the error? You're trying to minimize the error, right?
Yes. Mhm.
So that's what it is. The whole point of linear regression is minimizing the sum of square errors. It's just a concept.
Mm, okay, that's good. So we move to Sue's. We move
Yeah, it's
to
like at 6. I'm actually getting kind of hungry. I'm probably gonna get something to eat, and then you mind waiting? I'm gonna be back.
yeah, that's fine.
Okay. Yeah, try look at 7 too, like the other ones.
Yeah, let me look at 7. Okay, so predict the sales over zip code with the housing density of what? Report in decimal places. So round divide by 4.
right, I'm back.
That's fine. You have to get something to eat.
And I was super hungry. It's already 8 over here. Oh.
Yeah.
Okay. So,
Okay.
what number
So
are you on?
there are 4 lines on question A for the density. If the
For the density one?
yeah, right.
Are we in question 8?
When question, sorry, I'm ahead here of myself.
Okay.
Yeah, we are on question A.
Question 8. Okay. So for question 8, did you copy this one already? Did you put it on your own file?
Yes.
Okay. So what you usually would do, so like for this one, what is it asking you? It's asking you for the prediction interval, right?
Yes.
Do you know what that is? Like what the prediction interval is?
Yeah. So it's
We kind of did
basically,
we did something similar to this one, yeah. Like before, I think it was like 6.3, something like that.
yeah, that was I think it was
Oh,
6.3 or 6.4.
6.1, 6.1, I think this one's single. Yeah, I think it's 6.1.
Yeah. So pretty much a prediction. If let's say you estimate if a future observation is going to fall.
Okay, yeah, that's what that is. It's so like the way I usually would the way you would like code this in R is you have to get the linear regression first, right? You always do a linear regression.
Mm-hmm.
That's like the first step. And then so after you do line 48, like the linear regression,
Mm-hmm.
you have to take a look at the prediction. Like and then every time you predict something, you're always given something else, right? You're given like this is what it gives you. It gives you the what's it called? The level of your confidence interval, right? Your level of
Mm-hmm.
confidence is 95.
Mm-hmm.
And then the other thing is it gives you one of your predictors, right? Like it gives you a predictor.
Mm-hmm.
So you can predict your response, which is the sales. So let's try to look at maybe just copy, look at line 49, just copy try copy up to like line, like so 49 to just that line, but not the whole line. Just copy up to 95. So from that, from the beginning, yeah, just copy from that to like the 0.95, line 49. Just line 49. So yeah, copy, but then up to 0.95. No, not the whole thing. So up to the parentheses, up to the parentheses. I'll show you this what it is first.
Okay.
So it from there all the way to the parentheses next to the 0.95. Yeah, that one. Yeah, copy that and put that on the line 53.
Put on line 53.
Yeah, just put it there, and then I want to show you what's in it first.
Oh yeah, because I was wondering how they're so many repeated so many times.
Yeah, the reason why I did that, you could do it in many ways, but try click on that one, like run this.
Which one?
Just run 53, this
Oh,
line.
run it.
Yeah, run it, yeah. Okay, so do you remember looking at these three values?
Yeah.
So the prediction interval is the no on the bottom one, the bottom. No, not that one. It's this guy at the bottom. This guy. Do you remember looking at this?
This one.
No, like the bottom one. Not
Uh,
that one. That guy. Yeah, that guy.
okay. So that is. like 89.95%.
So this guy right here, this one, do you see my thing? This guy?
Yeah, right.
This one right here is that's the prediction interval.
Ah,
That's the prediction interval, PI.
ah.
The lower to the upper.
Okay, lower to the upper.
That's the prediction interval, yeah. It's really confusing sometimes, but what you need to do is you need to do a prediction given the confidence interval, which is
Mm-hmm.
the percentage, and they have to give you a predictor. So the predictor here is the density of the housing, and then you have to predict the sales response. Okay,
Mm-hmm.
and then so this is does it make sense why I did it 4 times now? I did it 4 times because it's saying which of these intervals is the narrowest one, right?
Mm-hmm. Yeah.
So what does the narrow interval mean?
Say that again.
What does a narrow interval mean? The interval, what does it mean to be narrow?
If it is, if it's narrow,
Yeah, what does that mean? Yeah, what does that mean when it's narrow?
I would assume that you can, the prediction is going to be higher.
If it's narrow, like the prediction interval, what does it mean for the prediction interval? That that means the interval is not far apart, right?
Yeah, like they're closer. They're not they're not wide apart.
Yeah.
So then the lower here is the 44.85 and the upper is the 135.5.
So that's why I took the difference, right? I took the
Yeah,
difference between the upper and the lower.
the lower.
Yeah.
So that's how you got. So the difference is the prediction interval
Yeah, the difference of the prediction interval,
between
yes.
the lower, yeah,
That
between the lower and the upper.
yeah, you got it, yeah. That's the one. So like when it's narrow like that, all you have to do is just look at the difference between those two, like those 4 things.
Okay, so
Does that one make sense?
is that why you had done this 4 times?
That's why I did it 4 times. Yeah.
Ah,
Yeah, and then so try print them. Like try running 49 to 52.
all of it?
Yeah, and then see what happens. So you see the numbers? It's 4 numbers, right?
Yeah.
And then which one is the smallest one?
So this is the smallest one.
This guy, right? This guy.
Yeah.
Let me erase the sun.
Wait a minute. No, it's not that one.
Is 90, right? That was 90. This was 90.
Okay, so yeah, okay, so it's 90, 105, 144, and 132. So the 90 is the lowest one.
Yeah. Okay. So what does that tell you? That means that's the narrowest one, right? The narrowest.
Oh, so that means that is the narrowest.
Yeah, that's what that means. Okay, does that make sense?
Yes.
Okay, let's move on to the next one. Can can you wait like 1 minute? I have to call this
Yeah.
person.
Right.
Okay, just try to like copy it and then I'll explain it.
Okay. Where did I get this from? Oh, okay, that's the answer. Somebody in the object.
Okay, I'm back.
Okay.
All right. What is this one asking us?
This is about it asks what is the standard error of the model predicting sales from density.
Okay.
And I don't know how you got the answer. I'm assuming you ran this one.
Yeah. So when you do that one, it tells you that what is the standard error, right, of the model. Uh, try and go back to question 9. I think there's more to it. What is the standard error of the model? Yeah.
Go back to which question?
Question 9. Okay, that is how I got it. Yeah. Let me look at this again. Let's see.
Yeah, because it asked me for the standard error of the model predicting the sales, but
Okay,
I don't see the
I think what I
the
did was
calculation.
se dot fit. Se dot fit. I did se dot fit. Se dot fit is the one that you have to do for this one. Let me look at that again.
Okay, cool.
Se dot fit, and then you have to make it equal true. I think that's what I did. Yeah, se dot fit. I probably like deleted it somehow. But all you have to do is, yeah. So predict.lm, predict, and then inside predict you have to put in the se.fit. So let me see how I did that one. LMNR. Okay. Predict. Let me see if I can run that with this guy. So se.fit equals true. Hmm. Oh, was it from? It's probably from the top one. Yeah, I think what I did was I took the top one.
So, are you
Yeah,
referring to line 46?
line 47. Yeah, line 47. I just took the very first one, which is like the narrowest one, and I put in SE that fit equals true. I think that's what I did. Let me see. Yeah, that is what I did. Yep. So if you take line 47 and then all the way to like 0.95, whatever you did earlier.
Okay, so I have to here. Okay, and then I can put it.
Yeah, just copy it to the bottom of that guy, 54, line 55. Okay, and at the end of level equals 0.95, try type this in. So comma at the end of 0.95, try after that one, try type comma, no, like inside the parentheses.
Or inside the parentheses?
Yeah.
Okay. And leave it like that?
Yeah, and then SE dot type this in SE dot fit equals true. Dot fit, like fit FIT. Yeah, that one right there. Equals true. True with like all capital letters.
Just regular letters?
Like all capital,
Or
everything.
all capital letters?
Yeah. And here you go, SE dot
And
fit.
here it comes.
That's the number, yeah. So like this one it was a little bit weird because it doesn't tell you like anything about what to assume. You know, it doesn't tell you what density and then what confidence interval.
Yeah, because I would not even know.
I think you need that one, right? I
Yes.
pretty much think you need the confidence interval and then the actual independent variable.
Mm-hmm.
Okay, so yeah, that's pretty much it. Like for that one, you just run the same thing and then SE that fit.
Okay. It's from line 37.
Okay.
Okay, plot the residual of model predicting cells from density. What is the biggest problem with this model?
So what? Let's plot the residuals of the model. Did I write any code for this one? Did I do any code for this one?
Yeah, there appears to be a nonlinear pattern. It looks like you had a diagram or some kind of graph.
Yeah, where is that one?
So is this, you go here,
Yeah, try look for that one.
Plot the residual model connecting.
Try where's the code that I have for that? The long resid plot. I think you have to do a residual plot for this.
So residual file.
Yeah, question 10.
This one.
Go to
No,
line
that's
10.
not it.
Line 10. Question 10. Question 10.
Question 10.
On my on the homework regression.
Oh, okay, gotcha.
Yeah. You see the line 60, yeah. Line 60 to 61.
Yeah, this one here.
Yeah.
Okay. So I'm moving it here.
I'll explain this one. So do you remember doing the residual plot? We did that one many times. But then we need to do ggplot. This is the reason why. This is the time that you actually need ggplot. Do you remember? I think you did this one actually, the ggplot.
Yeah.
Okay, just run this one first, and then we'll talk about it. Run 59 and 60, both of them. Yeah. Okay, they both. There you go. Try to look at that graph.
Ah.
Try to look at that graph. Graph looks really nice actually.
Ah.
Every time there's a graph, it's always like now it makes sense.
Ah.
Okay, so looking at the plot of residuals, right? What is this looking like? Like, what does it
Well,
look?
the bottom, the lower part, they seem to be closer
Okay,
to the X line,
okay.
and the upper part, they seem to be scattered
Yeah,
and
there's
white. The
yeah.
intervals are wider.
Okay, I think for this, like, I was thinking, maybe you can explain more. Like, you know how like looking at the selections, there's
Mhm.
like obviously like D is wrong, right? Everything is great. That seems like it's not the one. And then what about the other one? There are many outliers. It's not really a lot though, right? It's like a few only.
Yeah, like these ones here,
Yeah, but they're not many though. It's not
but they're
every.
not many. Yeah,
Yeah, so
they
it's not B. What about this one? The variance is not constant.
no, it's not.
But then we're not talking about like it's not constant, but what about the non-linear pattern in the residuals? It could be A or C, let's say.
Mhm.
It could be A or C, but like which one is it? Right? Can it also be like A, right? Non-linear pattern. It looks like it's curved. What do you think? This one could be like it could be the variance is not constant, but I don't think that's the problem, right? Like when the variance is not constant.
Yeah, and that non variant in
It's not constant. It doesn't. It's not a
it's not
problem.
constant. Hmm.
It's not a problem, right?
No. Mm-mm.
So that must mean that it's the other one, right? It must mean the non-linear one is the issue,
Um,
right? I think that's what it means. Have you heard of non-random before? Non-random patterns?
yeah, I've come across it, but I haven't read it like. Like you can talk about it.
Yeah, non-random
Simple task.
patterns is the same as non-linear. It's the same as non-linear.
Say that again.
Non-random is the same as non-linear model. And
Oh,
and then a random pattern is the same as a linear model. So like if you have like a bunch of you know, a non-random one is usually like a curve. You see a curve here, right? It looks like a S shape, right? It looks like an S. Like if you take a look at this looks like an S.
mhm. Yeah, it looks like kind of like some kind of S.
So
Uh-huh.
this right here, I think this just means non-linear.
So yeah, so this is non-linear.
And then like, I mean, yeah, you don't have the variance here. There's some variability in the variance, right?
Mm-hmm.
But there's no issue with that one, right? There's no issue with the variance. It's okay. But if you have non-linear, I think that is an issue. I think it'll be hard to find like a pattern. Is it? So I think that's the answer. What do you think?
Yeah, I agree.
Okay. I don't know how you would solve that one, but I guess we'll talk about that later.
Sure.
Yeah. But as long as you know, the main point is as long as when you see something like a curved line like
Mm-hmm.
this is non-linear.
Oh,
Yeah. That's it. That's really what it is. That's all it's wanting you to do. Okay.
all right.
I've already touched on this one again, but like how to actually solve it. Like, how to make it like linear. All right, so let's look at this one.
So the question is asking me which of the following values of correlation between X and Y will yield the strongest simple linear model.
Yeah.
Be careful on multiple terms. So simple linear model.
So let's look at like the choices for this one.
Okay.
So looking at the choices here, what can you tell me about what does it mean to have like a strong like linear model? What or strong correlation? What does that mean?
If you have a strong correlation, uh, that means that the relationship between the the variables are stronger.
So like, do you remember the correlation? It goes from -1 to 1, right?
Yes, between -1 and 1.
Okay. So I guess I'll just tell you this then. So if you have something closer to -1 and 1,
Mm-hmm.
that means it's a strong relationship. If you have a correlation that's like near 0, that means it's a weak relationship. That's just something you have to know.
If it is 0,
If it's close to 0, that's a weak relationship.
if close to 0.
Yeah. If it's close to -1 and 1, that's a strong relationship. Yeah. So like let's take a look at these values. The ones that's given to us. Which one has is closest to -1 and 1?
Um, let me see. Let me pull up my. I don't have it. I thought it was here.
Which one is the one closest? Do you see it, or do you see the choices?
Let me see. Let me get the hard copy. It's here.
What can you? What are you doing?
Yeah, I'm looking for the hard copy pack.
Oh, okay.
I thought I printed it. I have most of them printed.
I think I sent you this. You could just open that one. I think I sent you this one.
But it's gonna dislocate my app from the screen. Uh, Let me download that one. I don't know what I did with it. It's funny. Oh, here it is. I covered it with this.
Yeah, usually it's like that.
Yeah. Sorry about this. Yeah,
No, it's all good.
okay. So it is right here. I just had something written and put it on top of it. It's not even all of it. It has to do with number 4 is here. Big one. That is 6 1. That is 6 2 6 3. Ah, I didn't print all the pages. I only have up to question 4. So
Okay.
it's not helping me either. Let me download it.
Let's download it. Yeah.
Yeah, let me download it. I hope it doesn't take the R away.
Or which one?
My R.
Um.
Oh, okay. I see what it is.
Okay, just save it. Yeah.
Yeah. Okay. Okay. Let's see. Yes. Download.
Okay. Okay.
I don't know why Why it's not? I'm not getting it. What is that?
Oh, there's a lot of quizzes. You should send me all of that one.
Yeah, there are a lot, and I have not organized them well.
I can like write a code for each one ahead of time. I know there's, I mean, it's a lot, but I think it's not that bad.
Yeah, it's a lot. Every week you get like four, at least four. And
For a week.
sometimes, yeah, and sometimes you also have to go to data camp.
What is data camp? Is that like what is that one?
It is it's another company. So like some of the questions they give us,
Okay.
you log on to data camp. So through the school email,
Yeah.
and then you'll find like practice questions. Once you finish, then you start doing quizzes there. And then the answer goes to the teacher. The teacher will mark the answers.
And you have to do that and then this class.
Yeah, you do
It's a
that.
lot of work. This class
Plus,
is already a lot of work.
yeah, it's like you're busy. When you wake up, it's like you don't want to think of anything else. It's just this thing.
I mean, like, yeah, it does take off like most of the time. Over time, though, it's kind of fun. I mean, I'm starting to like each one of the
But I
quizzes.
like crazy things like this too.
It's a lot of work. Yeah, the data count one, I don't think I can help you with that one, right? It's like that's all you, right?
Which one?
The data camp or whatever. The one that you said that I can't help you with that one, right? The quizzes.
Oh, the quizzes, the next week quizzes.
Yeah, the ones that you've been sending me, I can do those ones. But like I haven't seen anything else unless you want me to do those as well.
Yeah, we can work on them too.
Let's do this one first though.
Yeah, I can't find this thing now. I don't know what has happened. Now I'm so confused with it.
It's fine.
There's so many there now. I can't get it.
Let's just take a look at the one I sent you. Go back to the one I sent you. Like
Okay,
in the email.
so I'll go back to my email
Yeah.
because the one I have in front of me, I don't know where I put the other pages. I have up to question 4. Then whatever happened to the other pages, I can't tell myself. That's shameful. Because I, I tend like to put them together. I don't know why this was not straightforward.
Okay. Go. So if you go to the email,
Second time, okay, email is right here.
because we can just pull out the PDF that I sent you. It's the same thing.
Okay. Yeah, here it is.
Okay, let's go to that. Let's go to that one. The one that we're on right now.
Go back to studio.
Which one are we on right now? The
Are on number 10.
okay.
We've done 9. Okay, so here I think this is the one. Yeah, that's the one we did. Then we move to this one. Yeah, so number 10 is where we had a question that you wanted me to.
We did that one already. Let's go to 11.
Okay. All right, so 11 is which of the following values of correlation between X and Y would yield the strongest simple linear regression model?
Yeah.
And then here we go. So you said that the closer it is to -1 and 1, that reflects a stronger relationship. If it's close to 0, the relationship is weaker.
Yeah.
So
So which one is closer?
then if
-1 or 1?
so then the one that is closer to 1.
Yeah, let's look at them. What I chose that one, negative
Yeah.
0.92. I think that
So yeah, since it's between -1 and 1,
yeah.
then the 0.85 is the stronger relation. It reflects a stronger relationship.
Okay.
Cause,
Okay, so
'cause one-
do you get that one then? Let's move on to the next one.
yeah. Okay. Then this one is asking me use. That's what I didn't know. Use the data in inkjet printers from log5 data package. Run a regression to predict price from ppm, follow time, cost BW, and cost color, which variables are significant at the 0.05 level. This one has lost me.
Okay, try to just copy that one first, the code.
So do we take it up to number 1?
Oh no, like only for 12, right? 12.
Which line?
Find question 12.
Go back to question 12.
Yeah, we're in question 12 now, right? Or 13? Where are we on? 12 or 13?
We are on 13.
Okay, copy. Oh, there is no. Yeah, so if you look at number 13, go to question the R again and then my R, the homework regression one.
Okay, so go to your R.
Yeah.
Okay, here we are. So question 13, use inkjet printer from log5 data package, run a regression prediction. And then, so this is,
Yeah, just copy everything from 71 to 74. Copy that, like all those. Okay. So let's try explain what that means.
Okay.
Yeah, you might want to like put in the question number so that way you can keep track.
Mhm. Okay, so I got that. And then I believe this is what I'm gonna have to run. Hmm. Oh my God.
What did you do? What happened?
When I clicked something in the environment window, I was trying to clear the Google thing, the Google page that was there for no, with nothing in it. And then I clicked the environment page, and then all the stuff got disappeared.
It's
But
fine.
they are back.
Yeah, it's fine. It's fine. Like we can definitely like redefine those ones.
Okay. All right. So I have inkjet printers. Uh, that this is the coding line.
Okay.
I ran it, but I got something here saying error. So I'm sure I did something wrong. Okay.
Okay. Let me see what's going on. Inkjet printers DF not found. So we have to define what that is first. Did we go up all the way to the? We ran where inkjet printers is, right? It's in log 5 data. So try go back to the beginning, to the top. Scroll to the top.
This one right here.
Yeah. So that one, yeah. Try to run that one, and then try go back to the bottom, and then run line 71. There you go.
Ah, so it's right here. It's not told.
Okay, run 72 to 74. 72 to 74. Pretty much the whole thing.
72 to 74.
Yeah. There we go. I think we're good now. So, what is this one asking us?
So
What is
it's
this?
asking us to use the inkjet printers from the log data, run a regression to predict the price of ppm, photo time, cost W, and cost color. And then it's asking which variables are significant at the 0.05 level.
So, what does it mean to be significant?
I really don't know.
So, do you remember like the p-value? I'm hoping that you can. Yeah, I know it's a lot of stuff, but the p-value. Do you remember the p-value?
Oh, so this has to do with the p-value.
Yeah, when someone's asking you if something is significant, you have to remember it's a p-value question.
P-value.
So, do you remember what is significant. Like, so if a p-value is less than what? Your alpha value, right?
Yes.
Alpha. So if your p-value
A
is,
smaller p-value means stronger evidence in favor of it.
yeah. So if your p-value is less than the 0.05, right?
Yeah.
That means this your the variables that you're trying to compare, there's a there's significantly there's a significance in them, right? They're significant. But if so, we just have to look at try scroll down, like go down the console. Let's look at what the p-value is. Um, go down more. Let's actually run like one of those files. Try go to line 74. I think it's like line 74. Right, yeah, line 74. Run that one. Run 73 first. Yeah. And then run 74. There you go. Sometimes it does this. R does this stupid thing where it's like there's a bug there. So that is the p-value, but also there's another p-value over here, right? On the if you look at like ppm, photo time, cost BW, and cost color in the coefficients. Those guys. Do you see that one? Here, I'll mark it so it's easier to see. So you see these guys right here?
Yeah, right.
And then if you take a look at this guy right here, this is pretty much the p-value. These are the p-values for each one of these guys. Does that make sense? Okay, so if what how is it significant again? If it's significant if you're if the p-value is less than 0.05, right?
Yeah, 0.05.
So which one of these values are less than that?
It's right here.
That's that one. That's the answer. That's how you pinpoint it. Yeah, it's just reading from a table. Okay, I think it's probably time to go. Do you want to just do another one later on?
Yes.
Okay. When are you? I guess when do you want to do the next one? We can talk about this and then the exam on the next one.
Yeah, we can talk about this on the exam. So let me know when you are available, then I just tweak my schedule around yours. That's it.
Friday, I'm good. I have no one for Friday and Saturday.
Okay. Check me
You
out.
want to do Friday?
Yeah, let's do Friday.
Okay, same time on Friday then.
Yeah, cool.
Okay, thank you.
Bye.
And yeah, I know it's a late time, but I'm glad that hopefully you learned a lot today.
Yeah, thank you. Thank you so much.
All right, have a good one.
You have a good one.